When two sets of data have a positive or negative correlation, you can use a trend line to show the correlation more clearly. A trend line is a line on a scatter plot drawn near the points that shows a correlation. So we can see two trend lines here. First with this positive correlation, and notice how the line itself, this trend line, seems to best fit those data points and show the trend that the data represent. Same thing on the right, as we have a negative correlation. You can use a trend line to estimate a value between two known data values or to predict a value outside the range of known data values. Interpolation is estimating a value between two known values. Extrapolation is predicting a value outside the range of known values. Problem 2, writing an equation of a trend line. This one's related to biology. Make a scatter plot of the data in the table. What is the approximate weight of a 7-month-old panda? Well, consider the table. Looks as though the left column is age in months. The right-hand column is weight in pounds. Age seems to be increasing 1 month at a time. 1, 2, 3, 4, and then it skips a couple, jumps to 6, 8, 10, 12. And then weight in pounds, 2.5, so measured to the nearest tenth of a pound, 7.6, 12.5, and so on. So we make a scatter plot. We treat those pairs from the table as ordered pairs, age as the horizontal axis, weight the vertical, and we plot the points. 2 points on the trend line are 4, 17.1, and 8, 37.9. So step 2 will be to write an equation of the trend line. So we'll use those 2 points that were identified to find the slope of the line. y2 minus y1 over x2 minus x1, practice with the slope formula, simplifies to 5.2. So the slope, remember, represents our rate of change. So for each month, we could expect about a 5.2 pound increase. Then we can use point slope form to continue writing the equation. Remember, point slope form, y minus y1 equals m times the quantity x minus x1, and we'll substitute in some known values and the slope that we just found to write the equation y minus 17.1 equals 5.2 times the quantity x minus 4. Simplifying and rewriting in slope-intercept form, which we often prefer for graphing and other reasons, we find y equals 5.2x minus 3.7. Now that we have the equation, we can use the equation to predict the weight of a panda either using interpolation, which would be finding the weight of a panda between ages 1 and 12 months, or extrapolation, if we wanted to estimate or predict the weight of a panda outside of the age range 1 to 12 months. So step 3, we'll estimate the weight of a 7-month-old panda, which is within the range of our data. So this is an example of interpolation. Y equals 5.2 times 7, representing 7 months, minus 3.7. Y equals 32.7. So our prediction, the weight of a 7-month-old panda is about 32.7 pounds. Your turn. Make a scatter plot of the data below. Draw a trend line and write its equation. What is the approximate body length of a 7-month-old panda? And B, a reasoning item. Do you think you can use a model to extrapolate the body length of a 3-year-old panda? Explain.